Hello and welcome to another episode of James Dean Designs, where today we are taking a look at 3D reliefs within Carveco Maker. Now the spectrum of what you can do with 3D tools is quite broad, so we're going to break this down to a couple of episodes and cover all the different tools in digestible portions. In today's episode we're going to take a very brief look at the Carveco 3D relief library, but mainly we're going to focus on importing our own 3D relief file, doing a little bit of manipulation and getting all the toolpaths ready so I can show you how I created this 3D dragon. So let's move over to the PC and get stuck in. So the first thing we need to do is create our new model. We're going to click the new model button. My piece of wood today is 150 millimeters wide, 200 millimeters high, and although we don't need the thickness at this stage, I'm going to reference that it is at 25 millimeters thick. You'll see shortly why I'm telling you that now. We're going to leave the resolution at full. This will give us the most detail in our 3D carvings on the simulations. And we're also going to leave the origin as the center of the job. Click OK and generate our model. Now within Carveco Maker there are two ways really to look at importing 3D reliefs. The first is to use the inbuilt library that comes with Carveco Maker. Now I'm not really featuring it in this particular video, but I will give you a very quick overview so you can understand how it works. This folder icon up here with the yellow star will open your relief library. There are folders containing lots of 3D reliefs that are all free to use within the software, and it is literally drag and drop. Bring them into your work area. You can use the anchor points around the outside to resize things, as well as the options down here on the right hand side. Now in this scenario it may be looking a little bit flat. If I rotate this around, we'll see this big red arrow, and we can adjust the Z height of it to really exaggerate the 3D relief carving. Now once you have it in position, you simply hit enter and it will make it a permanent feature on your model area. Now as I say, that this library is not really what we're covering today, so I'll undo all this, get it out of the way, close this library down and show you the other way to import your own 3D models. So we're going to come to relief, down to import and select import 3D model. Now in this folder we have the Dragon STL that we are working with today. Carveco Maker does accept lots of different file types for 3D models. They can all be found down here, but typically your most common ones will be STL files and OBJ files. So we're going to select that file, click open and import it. Now depending on the size of your file, it may take a few seconds to load it in. Obviously the larger and more complex file, the longer it will take, but when it loads it, you'll see something like this screen appear. Now the first thing we'll do is drag this out of the way so we can actually see what's going on with our work area to begin with. And if I rotate this around, what we can actually just see is it's sort of placed it in a really random position. So the first thing I'm going to do is click this center button, which will always put the relief in the center of your work area, and it just makes it slightly easier then to manipulate in order to get to the correct size and position that we want to work with. I'll also reset the view to standard just so we can see it in full view. Now in terms of this panel that opened up, there are a few options in here, as I say, to manipulate this 3D relief before we effectively make it permanent. The first option is the position of it. Now this is fairly self-explanatory, but we can move it around using these coordinates. So let's say we want to move it over 100 millimeters to the right hand side. Type in 100, click apply, and it would slide it over according to that offset. The same with the Y. Now I'm going to click that back to 0, press apply. The Z is slightly different, and let me explain why. Now the one thing we have to understand about 3D models in a semi-2D environment is that it can only really process it from the top down. So for example, if we take this bowl, now imagine your router or your spindle, obviously it can only really do vertical movements or left and right. So it can come down, it can machine all the middle of this bowl out, but it can only go down the side. Now the way this is handled is effectively anything that becomes underneath and shadowed gets blocked in, and it just fills it all in to make it a solid model. The easiest way to think about this is if you imagine a light or torch shining down on top of it, everything that becomes in a shadow is going to get blocked in. Now obviously if we flip this model over, it could then do all of this. It could do the underneath and down the side, but again it couldn't machine underneath because that would be part of the shadowed area. So just do bear that in mind whenever you are importing or working with 3D models. Let's carry on with the tutorial. So with that explanation, I'll sort of put it into view now. If we type in 10 millimeters, this will effectively lift the relief 10 millimeters off the surface of the model base. So we'll click apply. and you'll just see that raised up slightly. If I put it in this view, we can clearly see that gap underneath. Now, as I mentioned, the 3D reliefs in Carveco Maker do not handle the underneath, so that would all get blocked out and just blanked down to the top of your base model. So it's sort of one way to give it extra height if you're trying to lift the relief up. We can also take it down. So if we go -5, click apply, and it will sink it slightly below the surface. If I zoom in, this comes a little bit more clear. If we focus on this area here, where we can see some of it's above the line, some of it's below the line. Now, anything sitting below the line will essentially be deleted when we make this permanent and paste it down. The other thing I should also point out is when we go to paste it down, is anything outside of your overall work area will also be deleted. So in this scenario here, if we pasted this as it was, this nose area and all the teeth would all get cropped off, and the same with everything else all the way around it. This can sometimes have advantages, but 99% of the time you're going to want your 3D relief model sitting within your work area itself. Now, if we take a look at the rotational options, again, fairly self-explanatory by all of the symbols next to them, but we can play about with them and just show you what to expect. So rotating it on the x-axis will do something slightly weird in this scenario and effectively bury half of the dragon below on the axis for the model itself. So we'll undo that by placing -90 in and just revert it back to how it was. The good thing about all these settings is you can actually play about with them live and just undo or reverse the measurements that you put in to get it back to where you wanted it. Now with the Z one, this is probably the most common in order to rotate it on the work surface that you're on, and that will just maybe, if you want to orientate it to cut it horizontal instead of vertical, you can see how it affects it there. We'll revert that back to normal as well. And before we move on to the scale, I'm also just going to recenter this back to 0, 0, so it's sit on the dead top of the material itself. And you'll understand why in a second when we are talking about the Z size of this. Now, for the scale, all of these are linked in proportion at the moment by the ticks in the boxes. So effectively, if we adjust one axis, it will adjust it accordingly for the other two axes as well. So we know our material is 150 millimeters wide. So if I type in 150 millimeters, it's shrunk the other axis down as well. And this is roughly 70% of what it originally was. We'll click apply and we'll see what it has done to it there. We can still see it's sticking out the tops of it, so we'll shrink it even further. And now the material was 200 millimeters high, so let's say make it 180 millimeters just to guarantee that it sits within our working area. Now, if we notice on the Z size here, this has brought it down to about 13.5 millimeters, which is actually quite shallow. I'm going to apply this for the moment just so we can actually see it in view there. But what I really want to do is exaggerate the Z height just to give this a lot more depth. So we're going to unlink the Z axis here, and we're actually going to take this up to about 20 millimeters and click apply. Now you just see that got a lot more depth and a lot more detail, sort of exaggerated as we increase the depth. And I'll rotate this around and you can start to see it a little bit better. What we can see though is this is sitting slightly above the height of our model area, so let's just reset that again. And it is one thing to bear in mind that as you adjust some of these settings, it will affect the position as well. Most importantly, this Z, you always want to try and keep this on 0 whilst you are manipulating it for now. So we'll click that, click apply, and just put it back to normal. Now, one thing about doing this is you can use the Z axis sometimes to get the Z position, to get rid of some detail that you don't necessarily want. So in this scenario here, even though I wanted all of the dragon exaggerating and a bit deeper, I actually want to get rid of all these random little artifact bits around the outside. They're not really what I want as part of this particular job that we are doing, as well as some of this bits going on in the mouth of the dragon. So there are two things we're going to do to try and help get rid of one of these. First is to bury the dragon slightly below the surface. So if I type in -2, it's going to lower the dragon down just a little bit, but we click apply, and it gets rid of some of those bits because it's effectively burying them below the model line. But we've still got a decent amount of depth going on in the dragon. This can be a fine balance between sinking it below the Z line as well as increasing the scale to get what you are after. But for now, I am happy with where that is sitting. So what I'm going to do is click paste and make this model permanent on the work area. Once we've done that, we can just click the X to get rid of this box, and we can start to manipulate this a little bit more. Now, we just said I want to get rid of all these random artifacts around the outside, and what we can actually do is manipulate certain parts of this 3D relief without touching other areas of it, and I'll show you how to do that now. What we want to do is effectively cordon off all of these little bits around the outside so we can work on those without touching the relief. So we're going to use the polyline tool to do this. I'm going to zoom in slightly and start to draw a border all the way around these bits. You can do it all in one, so just keep the line continually going, and I'll speed this up on camera now so you don't have to watch me do all these individual clicks. Now I've just paused here because we've got one of these little artifact pieces that I want to get rid of, but it's sort of connected to the 3D model. So I'm just going to bring the line in quite close and just follow the edge of the 3D relief as tightly as possible with the polyline. And that way it can effectively cut it out of the 3D relief itself. So once that's done, I'll just finish off the rest of this border, which will just take me 1 or 2 seconds to click, so do bear with me. Now, at this point, we've sort of gone around everything, and the obvious thing to do at this point is almost come back to the start there, but that's not actually what we need to do. We need to go the other way around because we are cordoning this off from the rest of the relief. So we're clicking all the way around the outside now, just to finish off that vector. And ultimately what we've done is cordon this area off to say we just want to edit all of these bits around the outside. I should mention a lot of 3D reliefs, you may never need to do this, but it's just a useful feature to know should you ever need to make these edits. Now what we're going to do is come up to the scale relief tool up here. We're going to select that and we'll get a menu appear giving us a few choices. Now the first one is whether we want to edit the whole thing or just a selected area. So we want to mask and just use the vector area that we have created. And this basically is telling this tool to only operate in this area within the pink line that we have just created. The other options are about adjusting the scale of the relief itself. We've got a scale factor, or we've actually got a scale height. Now if I rotate the view around slightly, I mean, you can take this either way, either in positive or negative. So for example, if we really bump that up to 50 millimeters, you'll just see it spiked all those and really pulled that relief up. We actually want to do the opposite. We want to take this down to 0. So we're going to click 0, click apply. And then when I bring that view back, we can see it has now made it nice and smooth and got rid of all those little artifacts around the outside. So with that done, we can actually delete that vector that we created now, as it is no longer needed. We end up with a much cleaner looking dragon with none of those bits around the outside. Now before we move on to creating the toolpaths, there is one more step that we need to do to tell Carveco Maker that actually we only want to focus on this area where the dragon is. Now the reason I'm explaining this is when Carveco comes to interpreting your 3D reliefs, it sort of does it in one of two ways. It will either look at your entire work area and machine the whole thing, so all this dead space around here, it will try and machine that as well, and obviously this can take quite a long time. On occasion you may need to have the entire piece machined, so it is still useful to know that feature exists. But what we actually want to do is basically create a border around the entire 3D relief itself to tell Carveco Maker work within this zone. Just look at the 3D relief within this vector itself. This is a very easy process to do. So we're simply going to come to the vector tool menu, come down to the create option, and then down to the relief boundary. I will quickly explain the height range option. So what we'll do first is just click create boundary and you'll see what it does. It's put a boundary all the way around this 3D relief that we can now work to. However, if we use the height range option and it is set to 5 millimeters, it will just create a boundary around the parts of the relief that are higher than 5 millimeters. So if I click that now, you should see the difference in the way it jumped in, especially down here. So for example, the black line is the original one we created, the purple line is the new one we created, and it's just inset from the edge of the border. Now in this particular example, this is not what we require, but again, it's just one of those useful things to know if you want to create the border slightly inwards from the edge of your relief. So we'll delete that one that we just created and we'll work with the original one that we did to begin with. Now one other thing I will point out is you will see this one down here. There's a little gap in the 3D relief itself, so I'm going to delete that one out the way. And we just want to focus on this main outline border around the outside. Now another thing I like to do on my 3D relief carvings is just give it slightly wider border around the outside. This aids with cutting, but also aids when cutting the piece out because it just has extra space to work with. So what we're actually going to do is come up to the vector menu again, come down to the offset menu, select this, and we're going to put an offset border around the outside of 3 millimeters. So we've got 3 millimeters as the distance, outward is the direction, and we want to leave the corners as radius radius just to make it a little bit softer. And we also want to make sure the delete original vectors is also ticked, and then create that outline vector. And there we can see we have a border now all around our 3D relief, and it's got some nice softer corners which can often help when we cut this out of the material. So the next thing we want to do, we're going to close that relief menu down, that ball offset menu, and it's now time to start creating the toolpaths. Now for the 3D relief, it is this option up here where we can say see create machine relief toolpath. You can also access this by coming down to the project tab, going up to the toolpaths, and it is part of your full toolpath menu down here as one of the later options. So we're going to select this to bring up the toolpath menu to start creating our 3D relief toolpath. Now I mentioned earlier about Carveco treating 3D reliefs in two different ways, whether you want it to machine the entire area of your work zone or just a selected vector. We can see here by default it loads as whole relief. So what that will try to do is, as I say, machine all of this dead space all around the outside. What I actually want to do is just use the selected vector that we are working with. Now automatic boundary is very similar to what we did, but I actually find that the method that we did is more accurate, and as I say, it allows us to create that additional border around the outside for cutting later on. Select selected vectors, and it is automatically on inside vector, which is what we want. Obviously you can also do outside the vector if you're trying to machine two different things, again depending on your project. Now hopefully you may already be familiar with finishing and roughing. If you are not, then roughing option takes out a lot of the dead material in a quicker pass in order to make it much easier for the finishing pass to get you all of the detail. So it basically, you use a larger bit to hog a lot of material out, and then a smaller bit to put all the detail in that you require. And that is usually how we do 3D relief carvings. So we're going to go into the finishing option. Now usually most of the time then I'm doing 3D relief carvings, these are always going to be tapered ball nose bits. Now the reason that these are good is because they have a lot of strength, but also a small tip to give you lots of detail in your relief, and is one of the reasons that I particularly prefer using them. Now for the purpose of this video, I'm just going to select a 1mm tapered ball nose bit. We're going to, actually before I click select, I will just show you something. Now a really valuable thing in terms of knowing how to do your toolpaths is the step over with 3D reliefs, and this ultimately controls one of the levels of detail within it. Now we can see down here we have the step over in terms of a measurement, but also in terms of a percentage as well, and this can be quite crucial because when you read about people referencing 3D reliefs, they will often give their step over in a percentage instead of a physical number. In terms of detail for references, I would probably say anything below 10% is going to give you good detail, below 20% is medium detail, and above 20% probably starts to look a little bit rough and leaving lots of lines in there. So ideally I'd probably say you want to keep it somewhere between maybe 8 and 12% of the tip of your bit you are using. So this is on 10, which is perfect for us. Go and select that and just bring that tool in. I'll drag this menu down just so we can see a bit more of the options when we expand things out. If I open up the tool options, I'm not going to go through all the feeds and speeds because these are all relevant to your machine. The two important ones are the step down, because this controls how deep each cut is going to be, and also the feed rate itself. Now the reason I say feed rate is important is because when we are doing this, we are only taking a skim off each time on the horizontal movement. So actually we can usually increase the feed rate a bit higher than we typically want. So in this scenario, let's say it would normally be 1500, we could probably take this up to 2000 millimeters, for example. And in terms of the step down, imagine this as how hard the bit is going to be working. The lower the number, then the easier life the bit is going to have. The higher the number, it will clear more material, but will be a bit more hard work for the bit that is actually being selected. Now when we come down to the tool clearance strategy, there is one thing I should reference here. Whenever you are cutting within a vector like we are, you will only have the raster classic option available. There's nothing else in that particular menu. But if, for example, we come back up to the top and we change this to whole relief, come back down to that menu, we will see that we have a lot more options available. Now, certain options obviously give you different advantages. Spiral will obviously work from the middle outwards, spiraling across your material. So I'll just go back and put this to the selected vector that we are working with, and we're going to leave this on raster classic, but what I'm actually going to do is put this at a 45-degree angle. 45-degree angle is better on the eyes, and in terms of cleaning the material as well. I always used to think going with the grain got better results, but actually when doing 3D relief carvings, going at a 45-degree angle gives us much cleaner results and less cleanup overall at the end. I'm going to leave the rest of the settings in there as they are. Now the multiple Z passes, what I would probably say is these are like advanced options within Carveco Maker. 99% of the time just leave them as they are and you will be perfectly safe, but ultimately in this particular scenario you can control how many times, shall we say, the Z pass operates to create your 3D relief carving by adjusting the settings. But as I say, I usually leave them as the default and let Carveco Maker do all the hard work. Now in terms of the roughing options, this is about hogging as much material out before we do the finishing pass, so we can afford to get away with a much larger bit. Something like a 1/4 inch upcut or downcut is often ideal. Some people may also use a 1/8 bit, but obviously the smaller the bit, the longer it will take to hog all of that material out. Now again, we have the raster strategy. We can also do an offset with this one, which is where it will work from the middle and work outwards, or from the outside and work into the middle. But again, we're just going to leave this on a raster strategy for now. And in terms of the allowance, this is how much material is being left for the finishing pass to do. So what this is effectively telling Carveco Maker to do is calculate 0.5 millimeters worth of extra allowance, and that will then be the finishing pass that will take off all of that remaining material. Now I'm going to leave Z slices on automatic, but what I will reference at this point is this is directly linked to the step down within your roughing tool. So the step down is 3.175, and what it's trying to do is calculate how many times it needs to take slices out of the material to get to the desired depth. So in this scenario, it is going to do 6 passes at 2.912 to get to the desired depth that it needs to. I'm going to come back to this a little bit later on when we start doing the simulations, because it's easier to explain at that point than showing you now without doing those simulations. I don't want any leading or ramping for this, and what I'm just going to do is adjust my safe heights here. I'm going to expand this menu down. I'm going to put this back to 5 millimeters, and I'll put the Z home to 10 millimeters. Again, these are just my preferred settings. Now, before we click in to define the material, I'm going to explain a quick thing to you because it's a useful tip to know. Whenever you have a 3D relief carving like this and you put in your material thickness, it will effectively take the highest point of that 3D relief carving and make that the top of your material. Now in this particular scenario, there's one high point, but the rest of it all sits below the material. But if you've got quite a high 3D relief carving and your wood is not perfectly flat, you may find you start missing detail as a result of this. And I'll show you a quick tip to get around it in terms of offsetting the position of the relief in your material. So when we click to define material, we're going to put in the 25 millimeter thickness that my material is. Now normally you have these set to 0, but what we want to do is sink the relief slightly below the surface. So we're actually going to set that to 0.5. And what we can see then is just an extra bit of black line appeared. If I increase this, for example, and maybe make it 2 millimeters, and it is just controlling where that relief sits in the thickness of our material. So by putting it at 0.5 millimeters, it just means it's sitting slightly below the surface, and therefore every area of the relief is going to be machined, so especially if your wood is slightly uneven. Obviously, if you have very rough wood, you may want to make that top offset a little bit deeper. So we'll click OK now. And that obviously then puts the border around our 3D relief to indicate the thickness of the material and what is going to be machined. So for the most part, that's the hard work done. And what we can do now is give this a toolpath name. I'm just going to call it Dragon and click Calculate now. Now, I will say the simulations for this and generating the toolpaths can take quite a while depending on the complexity, again, of your 3D relief. So I'll just speed this up on camera as it generates all these toolpaths. So those are all our toolpaths generated, and you can see what we was referencing earlier in terms of within the vector or the whole relief. Because we selected to just do toolpaths within our vector, this is the area we were working with. But if we'd have selected the whole relief, it would have done toolpaths for all of this dead space around the outside. Now I'm quickly going to simulate this, and we'll just mess about with the settings a little bit to help you understand things like the Z slices. But ultimately what we have just created, it is this fairly good effect with the dragon detail. Now if I start to zoom in, pay attention to basically the edges on the scales, the sharpness of the teeth, and we'll come back to this shortly, but we're also going to take a look at the Z slices in the roughing pass as well. So I'm going to reset this simulation for the time being, and I'm just going to simulate the roughing toolpath first. So when we were talking about slices earlier, it is cutting through this material in layers. This isn't the easiest thing to visualize, but if I start to move this around, you can see that it's obviously doing one layer, working down the next layer. But these steps do look quite aggressive, and obviously this can have an impact on the way your job machines. If I zoom back out slightly, and we're going to come back up to the roughing toolpath menu, and where we had a step down of 3.1 millimeters, I'm just going to adjust this down. Let's say take this down to 1 millimeter. And if we come down to the Z slices, we will see that is now automatically updated to now do it in 18 slices. So this was originally 6 steps worth of slices. It's now going to do it in 18. So I'm just going to quickly calculate this and show you the difference, and look at how much softer the steps are in terms of the way it's going to machine. So if I delete the original simulation that we did, I'm just going to re-simulate that roughing toolpath again. What we can now see obviously is the step downs are much softer, and obviously this is better for the life of your tool, but the trade-off is ultimately it's going to take longer to do this because it's doing a lot more passes to achieve the desired depth. So there are trade-offs every time we do this. This will ultimately take longer, but it's better for the bits in terms of the life expectancy. Now the other thing I'll do as well, I'm going to put that back to 3 millimeters for now. And we're going to go up to the finishing tool. Now what I'm going to do is just change this for a slightly different radius tip. So what we were using earlier was the 1 millimeter tip. I'm just going to bump this up to the 2 millimeter tip. Now in theory this should only take half of the time of the original one, but if I regenerate the toolpaths for this now, and again reset the simulation, and then I'm just going to do the whole simulation again. And what you should now see is, although that, technically this job would be done much faster, what we actually start to see is less detail. Everything looks a little bit softer, a little bit rounder. So this is where the trade-offs start to come in terms of the bits you are using. A smaller bit will give you much more detail, but it will take a lot longer to machine. A larger bit will give you less detail, but take a shorter amount of time to machine. So it's finding the right balance that works for you. If time is not an issue, then go as small as possible with a small step over, and you will get a lot more detail in your carvings. Now for a lot of people, they may be happy with the quality of this. Given the type of 3D relief it is, I do want the most detail as possible. So what I'm actually going to do now is drop this right down to a 0.5 tapered mil bit. Select that. I'm going to reset the simulation and do all the toolpaths again for this, and just show you the difference again on screen once it's generated all these toolpaths. So with all the toolpaths generated, we'll redo the simulation. And hopefully what you should see is significant more detail in this carving, and hopefully that is really clear on screen. These edges are now much more sharper. There is a lot more detail in this, all the grain in this scale area. Yeah, basically this is really the difference, and I say the trade-off between quality versus speed and time. Now that is obviously the 3D relief carving done, but sometimes what you may want to do is cut out this piece from the piece of material that you are working with, and I'll show you how to do that now. So what we're going to do is come over to the original 2D view and select the outline vector again, and then we're just going to go back to toolpaths and select the profile tool. You may already be familiar with this tool, but obviously it's just going to allow us to cut it out. We're going to select along the line itself, start depth of 0, finish depth. Now the thickness of my material is 25 millimeters, so let's just make this 26 millimeters to guarantee that it cuts all the way through. Obviously you can select different bits depending on the type of cutout that you want. I sometimes find it easier just to use the last bit that I was cutting with. So in this scenario, it will be a 0.5 millimeter taper bullnose, and this saves me having to change the bit over during the job itself. If we're going to leave the cutting direction on climb, I'm going to leave lead in and outs turned off. I will add ramping on though, just with some default settings of mine. And I'm going to leave bridges turned off because I don't want them at the minute. You can obviously put bridges in. What I would say as a piece of advice is if you do decide to add bridges, put them in easier places to cut out. So normally on the straighter edges, you wouldn't try to bury bridges into these tighter corners here or this tight area here. Put them on the wider areas, the longer straighter areas where they're going to be easier to cut out. Now I'm going to just put this as profile cut, generate that toolpath. And what I can finally do now is just add this to the simulation, and there we have the cutout path is done. So what you should now be able to do is run this 3D simulation. It will do all the 3D relief work and then continue straight on to cut it all out using the tapered bullnose bit. Obviously, because we haven't added bridges in this particular scenario, you would probably hold the material down with something like blue tape and CA glue. So there we are, that is our project done and our first 3D relief carving. Let's just try changing the material over to something else that may work, something like a medium oak. And we see how it maybe then come out in wood. Now, what I would really stress is before you even attempt to start carving your first 3D relief is do play about with the settings. Do keep an eye on the times in terms of the cutting, you know, the cutting times itself, because ultimately these jobs can take quite a while, especially when we are doing step overs of things like 8 or 10%, which is quite minimal. These can take a while. So yeah, play about with the settings till you get to a point you are happy with before you start doing your first carving. But it is much easier than you think. You just have to dive in and get started. So we imported a 3D model, we manipulated it a bit and generated all the toolpaths to move on and get it cut out. Now earlier on in the video I spoke about the 3D relief library that's inbuilt. This works in exactly the same way. Once you drag those in and paste them down to your model, you create the toolpaths just as we did in today's episode. So it's very easy once you get stuck into it. Now in terms of the next episode, I'm going to be showing you how I did this 3D topographical map of Mount Rainier. So do keep an eye out for that one because it was a really cool project where we went full edge to edge and used all of the wood or material that we were working with. Thank you very much for watching. If you did enjoy this video, please give it a thumbs up and make sure you subscribe if not done so already. Final thanks as always goes to my patrons. I will see everybody on the next episode.